This is a problem that came out in the KZN March 2025 common question paper, and we are going to be learning how to do this problem. So I will make many examples and then we will do this specific problem at the end. But I'll teach you how to answer these type of questions, not just teach you how to write this to answer this one. So let's go ahead and do the first question. The first question will be, let's rewrite y is equal to x plus 1 over x in the form y is equal to a over x plus p plus q, right? So we are rewriting it in that form. How we do that for this one is pretty simple. We say y is equal to, this is a fraction, right? And since it has this denominator, we can take this denominator and distribute it to this part of the numerator and this part of the numerator. So that how that would look is you have x over x plus 1 over x, okay? Because you can reverse it back, you can take the same denominator and add the numerators. Now this is the same thing. It says x over x, which means it's 1. So you have 1 plus 1 over x. If we're writing this in that form, it has to be 1 over x. You can say plus 0, which is your p, plus 1, which is your q. That's how you do that one. Now let's move on to the next one. The next one is x plus 2 divided by x plus 1, right? That's your y. You have to write it in that form. So for this one, what you do is you say we need to have x plus 1 in the numerator. So how can we have x plus 1 in the numerator? So if we had x plus 1 in the numerator and x plus 1 in the denominator, what would we have to do so that this would be the same as this? You'd have to add another one here so that if these ones add, you get the 2 you already had there. Yeah? Now I'll put brackets here so that you can see that I want it to look the same as this. Now here we will do the same thing we did here. I need to here we set this over this and 1 over x. Right, so here we'll say x plus 1 over x plus 1 plus 1 over x plus 1. So x plus 1 over x plus 1 plus 1 over x plus 1. This is going to be 1 because it's the same thing. It's the same thing over the same thing. I don't know if that makes sense. And then you have x plus 1, which is this one. Write this first and put the 1 on the other side. So you have 1. So you have 1 over x plus 1 plus 1. Okay. Let's move on to the next one. The next one is x plus 3 divided by x minus 2. So for this one, you can pause the video if you want and try it. Now let's do it. So we want to have x minus 2 on the numerator. Basically, we almost always want to have what we have on the denominator on the numerator as well. So let's put x minus 2 there. But what would we have to add here so that this gives us 3? You can do this on the side. You can say minus 2 plus some value we don't know. I'm gonna name it a and equate it to 3, because we want to add something here such that the sum of those will give us 3, and say a transpose the 2 to that side. Yeah, you get a positive 5. So you add a 5 here. and check if it's reversible. 5 minus 2 is 3, right? And divide by x minus 2. Now let's put brackets again. You say this over this and 5 over x minus 2. That's going to be x minus 2 over x minus 2 plus 5 over x minus 2. Now x minus 2 over x minus 2 should be 1 because it's a number over itself. Plus 5 over x minus 2. Now let's write this first and write the 1 on the other side. You have 5 over x minus 2 plus 1. And this is this equation in the form a over x plus p plus q. Now let's move on to another one. The next one we'll do is a bit harder or a bit different. So y is equal to 2x plus 4 over x plus 2. So for this one, what you do is, whenever you have a coefficient in front of x, you take it out as a common factor first. So if you take out 2 as a common factor, you have x plus 2 in the inside, and then on the denominator you have x plus 2. Okay, that worked out not the way I expected. Okay, so basically this is going to cancel and you're going to have 2 as your answer. So y is equal to 2 where x is not equal to negative 2. Right. Let's try something without a 4 there. Let's say it is y is equal to 2x plus 5 divided by x plus 2. If you have this, you take out 2 as a common factor once again, and then you have x plus 5 over 2 divided by x plus 2. Okay, so what you want is, you want to have x plus 2 inside here. You want to have x plus 2 inside here. So how you get x plus 2 is, you say, well, this is 2 into x plus 2. And then you say, since you added 2, what would you have to add on 2 to get 5 over 2? So it's the same thing we did with the other question. You're saying, since we have 2, since we are forcing 2, what would you have to add on 2 to be able to get 5 over 2? So this can be reversible. So you have a is equal to, you transpose the 2. Now you have 5 over 2 minus 2. You have a is equal to, this is going to give you 4. You do this on a calculator, you're going to get 1 over 2. Okay, so you have to add 1 over 2 on this so that it can be reversible to 5 over 2. And then divide by x plus 2. What you do next is, you multiply the 1 over 2 by the 2, so you can take it out of the bracket, so that the bracket only contains x plus 2. So you have 2 into x plus 2. When you multiply this out, you're going to have 1, because 1 over 2 times 2 is 1. And then you're going to have x plus 2. Now what you do is, you say this whole thing divided by x plus 2. So 2 into x plus 2 divided by x plus 2 plus 1 over x plus 2. 1 over x plus 2. These are going to cancel, and this is going to leave 2, so you'll have 2 plus 1 over x plus 2. You can write this as 1 over x plus 2 plus 2. Right. Let's do another one. The one we're doing now is 4x plus 5 divided by x plus 3. So here, once again, you take out 4 as a common factor. 4 into x plus 5 over 4. If you take out 4 as a common factor, you have to divide the 5 by 4. And since, yeah. And then on the bottom you have x plus 3. Up here you want to have an x plus 3. So you force it to be there. So you have 4 into x plus 3. And then you go to the side. You say 3 plus a is equal to 5 over 4. Therefore, your a should be, you say 5 over 4 minus 3, which should be negative 2 over 4, right? Because 4 times 3 is 7, is 5, it's 12. Then 12 minus 5 is 7. So no, it's 7 over 4. Right. You write it on a calculator so you don't make these silly mistakes. So it's negative 7 over 4, and you can check by writing this. Say on a calculator, say 3 minus 7 over 4, and you should get 5 over 4. Right. Now you divide by x plus 3 again. What do you do now? You say now you have your x plus 3, so you multiply this by 4 so you can take it out of the bracket. So you have 4 into x plus 3. Since you multiplied these, the 4's will cancel and you have minus 7 outside, and then you have x plus 3 at the bottom. Now what you do is you say this divided by this, which is 4 into x plus 3 divided by x plus 3 minus 7 divided by x plus 3. And then these are going to cancel. You have 4, and then you have this. Now let's just go straight into saying negative 7 over x plus 3 plus 4. Right. The next one we'll do is y is equal to x plus 4 over negative x plus 2. Here we have a negative on the denominator. What we want to do is we want the x on the denominator to be positive. So let's take out the negative as a common factor. So if you take out the negative as a common factor, you have x plus 4 divided by negative 1 into x minus 2, right? Now, try to do the same thing we've been doing here, but this will be a bit easier because it's just x plus, it's x minus 2 to get what we have on the denominator, but then we have to add something to get 4. What do you add to minus 2 to get 4? You add 6. You can do the method where you say minus 2 plus a is equal to 4, and then you transpose the 2, you get 6. Then you divide by negative into x minus 2, and then you say this divided by this, and 6 divided by this. What's going to happen there? You're going to have an x minus 2 divided by negative into x minus 2 plus 6 over negative into x minus 2. Okay. Now, this is going to be 1, but it's going to have a negative at the front, so we're going to have a negative 1 here. And this negative, we are going to move it up to here, or the 6. We'll move it up to the 6. So we have plus negative 6 over x minus 2. Right? Because the negative can be anywhere, it still means the whole thing is negative. Now let's take this and write it on the front. We have minus 6 over x minus 2 minus 1. Okay, finally, we are going to do the last one, which is the one I promised at the beginning of the video. Let me get another piece of paper. So this one is the question they had on the March test. They say, given this, show that f at x can also be written as this. This question is basically asking you to take this and write it in the form a over x plus p plus q. So we are just gonna do that. So the function f at x is equal to 2x plus 3 divided by negative x minus 3. If you want to try this, pause the video and try it, and then see and watch the video continue so you can see if you're correct. So what we'll do here is two things. The first one is we'll take out a negative as a common factor at the bottom, and the second one is that we'll take out a 2 as a common factor at the top. So we'll take out negative here and take out 2 there. So it's 2 into x plus 3 over 2. We've been doing that. And then you have negative into x plus 3. Okay. Now, f at x is equal to, you want to have an x plus 3 at the top. So you force it to be there. But if you have 3, what number do you have to add to 3 so that you can reverse back to 3 over 2? So a must be 3 over 2 minus 3, which is, this is 6, negative 6 minus 3 is negative 3. So a is equal to negative 3 over 2. So now you say negative 3 over 2. So this will reverse you back to that. And another way you can look at it is, this is half of 3. This is 3. So if you remove half of 3 from 3, you're going to get half of 3. But you have a calculator, so you don't have to go through all that hassle. And at the bottom you have, okay, x plus 3. What I'm going to do is, the negative sign, I'm going to take it now and put it here on the numerator, the negative sign. Then you have f at x as, you multiply the negative 2 with this, so you can take it out of the bracket. So you have negative 2x plus 3. You leave that part. If you multiply these two, you have positive. The 2's will cancel, and you have 3, all divided by x plus 3. So f at x will be, you take this, you divide by this. So you have minus 2x plus 3, all divided by x plus 3, plus this divided by this, 3 divided by x plus 3. Now this will cancel this, and you have f at x as, let's write this at the front, so you have 3 over x plus 3 minus 2, and that is your answer.